So, I'm Juvel Kalwalatian, and this is my video presentation, and this is a course project in Data Communications and Networking 3. So, I choose the topic about dynamic routing, EIGRP and EIGRP tuning and troubleshooting. So let's proceed. So first is dynamic routing. So dynamic routing, and this is the purpose of dynamic routing. So scale, automatic updates, administrative mistake avoidance. Okay, and then, so what is dynamic routing? So dynamic routing is a process of selecting the best path or a data packet must follow through a network to reach a specific destination. Known as adapting routing, dynamic routing is a technique where a router obtains routing information about an administrator assistance. So the router adds the optimal path to the routing table and determines alternative routes. So if the primary path becomes less ideal or unavailable, dynamic routing also refers to automated path planning methods that compute routing operation through protocols and complex algorithms. So, how dynamic routing works? So, the router send and receive routing messages on the router interfaces. So, the second one is the router share the message and information with other routers using the same protocol. And router exchange routing information to uncover data about remote networks. In this way, when an internet gets reconfigured or a router goes down, each routing tables can undergo proper adjustment. And then when a router discovers topology modifications, the routing protocols advertises these changes to other routers. The next one. So what is the advantages of the dynamic routing? So exchange of routing information. With dynamic routing, routers can swap routing data when topology adjustment occur. The information exchange empowers routers to learn about new network automatically and discover substitute path and when connection to current network fail. Then the error reductions. So reduction. Dynamic routing helps reduce the chances of committing errors. That's because it runs path planning methods mechanically. So scalability. So dynamic routed networks can enlarge quickly with fewer administrative overhead costs. That because network topology adjustment required minimal effort. Let's go to this. So this one is still advantageous. So problem rectification. Dynamic routing can connect problem in the network and keep functioning when the network breakdown or the configuration fails. And then adaptability. So dynamic routing adaptability relates closely to its scalability. Whether inter-network grows or fails, the network can learn about the change and adjust accordingly. It can also reroute in response to the modification without any manual intervention. So, the dynamic routing limitations. So, complexity. Dynamic routing is complex to implement initially. When a router adapts to network changes, it must always remove wanted information from the routing table. This kind of scenario increases the complexity in the routing protocol. And then resources. Dynamically routed networks required additional resources. So, CPU, memory, or RAM, and link bandwidth. To calculate dynamic routes, hold routing tables, and perform other tasks. So, dynamic routing also requires knowledge of supplementary commands and communication. So, some or all machine in a network might not speak any dynamic routing protocol or a common protocol. So, this one is still limitations. So, bandwidth shortage. So, dynamic routers constantly communicate with one another using a dynamic routing protocol to share network topology information. This continuous exchange required more bandwidth. So, the messages can also cause bandwidth shortage when routers communicate with a low speed link, especially in expansive and unstable networks. And then the fourth one is security. So dynamic routes pose network security hazard because of the broadcasting and multicasting updates. So routers constantly exchange and advertise or send out complete routing tables and critical information. So example, IP address or of two routers across the network. Then securing dynamic routes requires added configuration settings such as routing protocol, authentication, and passive interfaces. So, this is my example of dynamic routing protocols that are commonly used in computer networks. So, OSPF, so it means Open Shortest Path First. So, OSPF is a link state routing protocols that is used in large-scale network. It determines the shortest path between the sources and the destination by considering several factors such as network topology, link cost, and bandwidth. So the next example is BGP, Border Gateway Protocol. So BGP is a inter-domain routing protocol used by ISPs to exchange routing information between their networks. It uses a path vector algorithm to select the best path of a packet to reach its destination. So RIP, Routing Information Protocol. So RIP is a distance vector routing protocol that is commonly used in small to medium-sized networks. It calculates the shortest path based on a number of hops between the source and the destinations. So this one is the EIGRP, Enhanced Interior Gateway Routing Protocol. So this one is a hybrid routing protocols that combines the feature of both distance vector and link state protocol. It is used to large scale networks and is known for a fast convergence time. And then the last one is ISIS, Intermediate System to Intermediate. So this is my example of dynamic routing. So role of dynamic routing protocol, like that. Then dynamic routing protocol exchange routing information between the routers, dynamically learn information about remote networks, determines the best path to each network, automatically learn about new networks, automatically find alternate paths if needed, link failure in current path. So that is the protocols, and that's all, and thank you. And then we'll proceed to EIGRP. So wait, so first, what is EIGRP? So EIGRP is Enhanced Interior Gateway Routing Protocol, or EIGRP. Automates the routing decision and configurations in computer networking. So Cisco designed the protocol and is available only on Cisco routers. So minimum bandwidth is used from the source to destination, and the delay is measured using metrics of a network. This is an advanced protocol to measure the distance and uses both link servicing and distance routing. Hence, it is called wait, sorry, I forgot, sorry. Oh, this is called, sorry for the delay. So this is an advanced protocol to measure the distance and use both link servicing the distance routing. Hence, this is called of hybrid protocol. It transitions well with IPv6, and has the support of IPv4 as well. This is a classless routing technique. Two routers are connected and the network is shared in EIGRP. So again, what is GIRP? So Enhanced Interior Gateway Routing Protocol is an advanced distance vector routing protocol based on the principle of an interior gateway routing protocol. It has a unique characteristic that improves the operational ability and fast converging rate. It can determine the shortest path distance vector, and it works on the principle of interior gateway routing protocol, a classes routing protocol. So it uses metrics like bandwidth, load, and delays to calculate the shortest optimal network route. So it is a technologically more advanced distance vector based routing protocol. To exchange information using EIGRP, first the foremost, the routers need to become neighbor to EIGRP. Then EIGRP uses multicast address to share the information. So the fundamentals of EIGRP. So EIGRP is a dynamic routing protocol used for routers decision and configuration. So EIGRP only send incremental updates, which in a short reduces the workload of the routers and the amount of the information transmitted. EIGRP is a classic hybrid protocol that supports classes routing. It supports automatic and manual summarization on a EIGRP enabled interface. It MD5 authentication on routers running EIGRP and also has maximum hop count close to 255. EIGRP performs load balancing over the equal cost path and unequal cost path. So neighbor table. The neighbor table contains information about routers and neighborship relationship with those whom have been established. Command to list router information show IP EIGRP neighbors, and the neighbor tables has field like age, handle, address, interface, hold time, uptime, smooth round, trip time, and retransmission timeout, queue count, sequence number. That's the neighbor table. And then I make the example of neighbor table. So this is the neighbor table. Okay, then let's proceed to topology table. So topology table holds information about all the paths to network understood by EIGRP routers. Command to list router information show IP EIGRP topology. The topology table holds the following fields: passive, visible, distance, advertised distance, visible distance. So this is the example of topology table, like that. So table dissected. And this is the routing table. The routing table stores the routes which are currently active in sending packets to the network. It stores the optimal route for the destination from the sender. Command to list router information show IPv6 route. The routing table holds the following field: D 90/5/632 via 11.0.0.2 gigabit Ethernet 0/1. So that is the routing table, and this is the example of routing table. And then packet types. Hello, it determines the neighbor route and also serve as a keep alive mechanism between the routers. If router X is connected with router Y and the router X is not receiving the hello packets from router Y, then it assumes that router Y is not reachable and the network is down. Updates are to send the information about the route to its neighbor. When a new router is found, the update packet sent to neighbor to build the topology table. And then carries are used specifically for requesting route info. They act as multipart until they send receive queries as the response. It will send the queries only when the destination state is active. And then reply packets respond to query that indicates the originator router, that is, does not need to go in the active state as reliable successors for the destination network. Replies are sent when destination go into active state. For the reply packet, an acknowledgement is sent. So acknowledgement packet will be sent to Enchant's interior gateway routing protocol query, update, and reply packets. It is address and also acknowledgement not sent to hello packets. And that is the topic about EIGRP. And that's all. And thank you. But, oh, wait. I still have one topic. So, IGRP, tanning and troubleshooting. So, let's proceed. And this one is the EIGRP, tanning and troubleshooting discussion. So, I put the table here about components of troubleshooting. IGRP components. This is diagnostic, diagnosing EIGRP connectivity issues. So, that's the issues. And then, let's proceed. So, network topology. Serial interfaces and their bandwidths may not reflect the more common types of connections found in networks today. So, the bandwidth of serial links is used in the calculation of routing protocol metrics and the process of the best path selection. So, the bandwidth command will be used to modify the default serial bandwidth of 1.544 kbs. So, let's proceed for the example of network topology. So, this is the example of network topology for IPv4 topology. So, this is also the starting IPv4 interface and EIGRP configuration. So, EIGRP, automatic summarization. So, routing summarization is one of the most common methods of tanning EIGRP. Route summarization works by grouping multiple networks together and advertising them as one larger network or summarized route. EIGRP can be enabled to perform automatic summarization at classful boundaries. EIGRP automatically recognizes subnet as a single class A, B, or C network and creates only one entry in the routing table for the summary route. So, this is the summarization. So, for routers to find the best route for each individual subnet information must be sent in the example above. Automatic summarization should be disabled so subnet information will be sent. So, this is the automatic summarization at classful network boundary. This is the classful networks. Default mask, class A, IPVR routing table. This is the IPVR routing table. So, explanation about IGRP automatic summarization. So, routing R1 and R2 are both configured using IGRP for IPv4 with automatic summarization. So, this one is R1 has 3 subnet in its routing table. So, that one. That one. So, these subnet are also considered part of a larger class B network. So, this one. Then, when R1 send its routing table to R2, it will send the 172.16.0.0 over 16 summarized network. So, this one is the configuring IGRP automatic summarization. Automatic summarization is disabled by default for IGRP IPv4 beginning with Cisco iOS release. So, 15.0 1M and 12.233. So use the show IP protocols command to determine if EIGRP automatic summarization is disabled. So to enable automatic summarization for EIGRP, use the auto summarization command in router configuration mode as shown in figure to the left. So this one, wait, I will show you later. So use the command no auto summary to disable automatic summarization. So this one, the configuring EIGRP automatic summarization. So verifying auto summary. So show IP protocols. Output from the show IP protocols command on R1 show that automatic summarization is enabled. Output also indicates the network that summarize and on which interfaces. Notice that R1 summarizes two network in its EIGRP routing updates. So this is the gigabit Ethernet and serial interfaces. Please refer back to figure in slide. This one. Okay. Sorry. So this one, the verifying auto summary show IP protocols. So summary route. The scenario in the figure walks you through an example of how automatic summarization could also cause a routing loop to occur. So that one. So this is the summary route. So example of routing loop. This is the example of routing loop. Like that. Okay, sorry. Like that. And that's all, and thank you for listening. Thank you for listening, and that is my course project. Thank you.